Hello everyone, my name is Karisna Sudarman from Actuarial Science Batch 2025 Class 1. So today we're gonna learn about the integration of fractional functions. And first of all, here is the learning objective. So the audience are expected to be able to understand what rational functions are, determine when partial fraction decomposition is needed, decompose rational functions into simpler fractions, and integrate the rational functions using the appropriate methods. And the last one is solve the problem involving repeated and irreducible factors. So, what is a rational function? A rational function is a function in the form of px over qx, where the px and qx are polynomials, and the qx is not equals to 0. And I also attached the examples. As you can see, the number 1 and number 2, here are the examples. Now, before we'll learn deeper about the integration of rational functions, here is the strategy or tips that you need to take a note so you can do the integration easier. So the first one is you need to simplify the rational function first, or use the polynomial division if it's necessary, and then decompose into partial fractions. And the last one is integrate each simpler fraction separately. Okay, so if you don't know, partial function is used when the numerator degree is less than the denominator degree, and when the denominator can be factored. So if the degree of px is more than the degree of qx, so you need to perform a long division first. Now let's move on to the types of denominator factors. There are 3 types. The first one is distinct linear factors, the second one is repeated linear factors, and the last one is irreducible quadratic. I also attached the examples below, as you can see, and I will explain it deeper on the next slide. Okay, so let's move on to the distinct linear factors. So if you guys see factors this type where px over x minus a times x minus b, you need to rewrite it as a over x minus a plus b over x minus b, where the a and b are constant. Now, this is the example. If you have an integral of 3x plus 5 over x plus 1 times x plus 2 dx, the first step is you need to rewrite it as a over x plus 1 plus b over x plus 2. And then the next step is you need to multiply it by the x plus 1 times x plus 2, and you will have this, where a times x plus 2 plus b times x plus 1. After you have this, you need to expand it, and it will become like this, and then you need to factor it out to solve the a and b. So if you don't do the factorization first, it will be hard to solve the a and b. Now, how do I know that a plus b is equals to 3? As you can see here, on the left side, there is 3x equals to a plus bx. So that means that a plus b is equals to 3, which means a is equals to 2, and then 2a plus b is equals to 5, so the b is equals to 1. Now we only need to rewrite the integral. We substitute the a and b, which is the 2 and also 1, into the integral. And then the last step is we only need to integrate the integral. Here is the final answer, which is 2 ln x plus 1 plus ln x plus 2 plus c. Now, if you already remember the distinct linear vectors, we're gonna move on to the second type, which is repeated linear vectors. So for repeated linear vectors, you need to rewrite it as a1 over x minus a plus a2 over x minus a to the power of 2, etc. until an over x minus n to the power of n. I know it's kind of complicated if you only see the formula, so that's why I'm gonna give you the examples and also the step how to do the integration. As you can see, there is an integral 1 over x times x minus 1 to the power of 2 dx. So the first step is we need to rewrite as a over x plus b over x minus 1 plus c over x plus minus 1 to the power of 2. And now we need to multiply it by x times x minus 1 to the power of 2, and you will get this result, and then you need to expand it. And after you expand it, you need to expand it a little more and then factor it out, so it will be easier for you to find the b and also c, which is the constant. Now we're gonna solve it. So here it is. You have a plus b equals to 0 and also minus 2a minus b plus c equals to 0, where a equals to 1. We only need to substitute the a, so it will become 1 plus b equals to 0, which is b equals to minus 1. And then, after we know the a and b, we only need to substitute the a and b into the next calculation. So it becomes minus 2 plus 1 plus c equals to 0. And we have the c, which is equals to 1. Now we only need to substitute the a, b, and c, as you can see here. And then we need to rewrite the integral. After we rewrite the integral, we separate the integral. So there is the first integral and the second integral. The first integral we already integrated, so it becomes ln x minus 1 plus integral x minus 1 to the power of minus 2 dx. Now we only need to calculate the second integral, which has become minus x minus 1 to the power of minus 1. And after this, the final answer will become ln x minus 1 minus 1 over x minus 1 plus c. Okay, now we'll move to the last type, which is irreducible quadratic vectors. So, if you have a vectors which is x to the power of 2 plus 1, you need to write it as ax plus b over x to the power of 2 plus 1. And the numerator must be linear. Okay, so here's the example. If you have an integral of 2x plus 3 over x to the power of 2 plus 1 dx, you need to separate the integral. So the first integral is 2x over x to the power of 2 plus 1 dx, and the second integral is 3 over x to the power of 2 plus 1 dx. Now we need to calculate the first integral. So let's say u is equals to x to the power of 2 plus 1, then du will become 2x dx. And then after this, we know that the integral of 1 over u times du is equals to ln u. Now we only need to substitute the u, so the result of integral 1 is ln x to the power of 2 plus 1. And then the next step, we need to calculate the second integral. And now, for the second integral, as you can see, you may move the constant into the front, and then you integrate the following integral, which is integral 1 over x to the power of 2 plus 1 dx, and the result will be 3 tan inverse x. And now, the final calculation will become ln x to the power of 2 plus 1 plus 3 tan inverse x plus c. Okay, so that's it for the types of denominators. Here are some exercises that you may do by yourself, of course. I think that's all the explanation from me, so thank you very much for watching. Bye bye.